Welcome to lesson 2.3 on graphing quadratic functions in vertex form. You guys have been getting awesome at doing this in class. We've gone over the shrink and stretch. We've gone over the reflection and the HK shifting, which is called translation. Don't forget the vocab with all of this. So again, this is just a review right at the beginning of this. The vertex form of a quadratic function. The vertex of the graph of a quadratic function in vertex form is HK. A indicates a vertical stretch or shrink or a reflection across the x-axis. H indicates a horizontal translation, and K indicates a vertical translation. Okay, so I think you guys have gotten really well versed at this. We've played a lot with these, so this is kind of a review lesson. A zero of a function is an input value x that makes the f of x become 0 on the graph. They're spotted right there where they cross the x-axis. Those are the zeros of the function. Really important, so we want to always make sure and look at the zeros. For the function 2 parentheses x minus 3 parenthesis closed squared plus 1, what are the values of a, h, and k, and what do each of these values indicate about the graph of the function? Okay, so you look back at the formula, and the a would be 2. It indicates that it's stretched by a factor of 2. The 3 is the h value. It is a positive 3, so it does go right 3. Remember, the negative is in the function rule, and so when there's negative there, it means that a positive was plugged in. The plus 1 is your k value. It causes it to shift up 1. And that's what I would expect you to write down there, is everything that I just said. Rewind the video if you need to listen to it as you write. I think that you know that probably. You should know that. Come and practice with other kids in the class, please. Okay, 1b, explain why the vertex of the graph of a quadratic function in vertex form is hk. This is because the vertex form actually allows us to see where the vertex is. So when you have y equals a x minus h squared plus k, you can see your vertex right here, hence the name vertex form. So that is your vertex right there, and I highly suggest that you actually pull it out just like that when you're graphing. The other thing, just let me give you an example. Let's say we have y equals 1/2 x plus 3 squared minus 4. Again, because that plus is there, remember that the original formula or rule as a minus, that tells you with a plus there that it's a minus -3. So that would tell you the vertex is -3, -4. And you would just write that as your vertex. And that is the first thing that I use in graphing these, is I go to the vertex first, the vertex being the turning point of the graph. Okay? If you estimate a zero of a quadratic function from a graph, how could you use the algebra to check your answer? Well, if you're estimating the zero of a function, it means that you're saying that the f of x or the y is equal to 0. So you can always take the function rule, whatever they give you for the equation or for the graph, whatever it might be, and plug a 0 in there for the f of x to check and make sure that you've estimated correctly. A graphing location is truly an estimate. You always need to plug it in and see if it comes out true. Okay. Now, in example 2, it says to graph the function 2x plus 1 minus 2. Identify the vertex, the minimum, the maximum, the axis of symmetry, and the zeros of the function. You guys have been doing great with these in class. I would pause the video, try to do it on your own, and then turn it back on and see what I've done. The h would be the -1. Again, because it's got a negative in the rule, that comes out as a -1. The k is -2. So the vertex is -1, -2. And with that, I just go right ahead and I look at it. It's going to be a regular shape like this. There's no negative out front, so I know it's the minimum. And I also know that my minimum value is my k, right here. This is my minimum. So it would be a -2. Because it's a positive a, I have that it's a minimum. So that's with a positive a, the positive number out front. If it's a negative in front of the a, then it becomes a maximum. Now remember, those names come from that being the maximum point that can be reached on that graph. This is the minimum point that can be reached on that graph. So it is the k value. The axis of symmetry is always your h value. Okay. And now let's graph it. Okay, the graph is at -1, -2. It is a stretch of 2. Remember on the parent graph we would go over 1, up 1. Now we'll go over 1, and instead of going up 1, we multiply that by 2. So that would be up 2. And it's got the axis of symmetry right through the vertex. So any point plotted on one side of that axis is reflected to the other side. Normally we go over 2 and up 4. We'd take 4 times 2, so it'll be up 8. So 1, 2, 3, 4, 5, 6, 7, 8. And now connect your points into your parabola. Okay. Identify the zeros of the function. The graph appears to cross the x-axis at the points 0, 0, and -2, 0. So the zeros of the function appear to be at 0 and -2. This is your x values. And that's the points at which the graph is crossing the axis. Okay? That's what x is equal to when y is 0. How could you use the value of a to determine whether the function has a minimum or a maximum? Well, I don't actually talk about it being the value of a. I like to think of the a having an absolute value, and we just simply look at the plus or the minus out front. If it's a minus, it's a maximum. If it's a plus, it's a minimum. Okay? So you need to write that in your own words and study that. How could you use the table in part B to confirm that you correctly identified the zeros of the function from its graph? Well, in part B, if you look up here, they have x equaling -2. They also have x equaling 0. So when we plug those in to the equation, into the function rule, we should end up with y equaling 0. Let's just do that real quick. -2 plus 1 would be -1. -1 squared is +1. +1 times 2 is 2. 2 minus 2 is 0. So that one works. 0 plus 1 is 1. 1 squared is 1. 1 times 2 is 2. Minus 2 is 0. So that one works. You should go ahead and fill this table out. Okay, next page. Write the vertex form of the quadratic function whose graph is shown. I had a student who just got really good at these really fast, and he explained it this way. He said when he sees the graph, he always thinks HK is the vertex, so right over top of the vertex, the turning point of the graph, he writes H and K. Then, on the top of the other point, he wrote X and Y. Okay? Now, he simply takes the parent function, and he actually plugs in those values. I'll put the HK in here first. So 2 for H, 2 for K. Sorry, I wrote those at the wrong spots as I said the names, but that's what they are. And then he substitutes in the X and the Y in the equation as well. The 2's are in there. And now he substitutes in the X is -2, Y is -6. So -2 minus 2 is -4. -4 squared is +16. Minus 2 from each side. We get -8. Divide each side by 16. And we get -1/2 when we reduce that. So now you need to make sure and put your HKs up here back into the formula where they are located, and then bring that A value in there. So to rewrite it again, you could also write it with the Y. Y equals -1/2 X minus 2 squared plus 2. This is your vertex. Double check that that's right. This is your A value. You can double check your math here and see if it's right. Okay. How can you tell by looking at the graph that the value of A is negative? Again, you can just check it out front. The negative indicates it should be a maximum going this way with a maximum point, and that's what we have up here. Okay. On 3b it says describe the graph of the given function as a transformation from the parent graph. So the first thing that I would list is that it's reflected over the x-axis. It is shrunk by a factor of 1/2 or compressed by a factor of 1/2. That it is shifted to the right 2, and that it is shifted up 2. Okay. Okay, example 4. They want to do some modeling. These are the fun ones. I really enjoy these. You guys have been doing great with them. The shape of a bridge support can be modeled by f of x equals -1/600, parentheses x minus 300 squared, plus 150, where x is the horizontal distance. I always like to underline that. X is the horizontal distance in feet from the left end of the bridge. So down here on your x-axis, immediately stop and go find the numbering and write the horizontal distance and put feet right there so that you remember that axis in graphs totally help you understand the context. Without that, you don't know what you're dealing with. So this is 120. That means half of that would be 60. So we're going by 60s. So 120 plus 60 is 180. Then we'd have 240, 300, 360, 420, 480, 600. Actually, we're going by 60, so that would be 540 and then 600. Okay, now we read a little bit further. That's from the left end of the bridge, and f of x is the height in feet. F of x is your dependent variable. Okay, so it's the height of the bridge in feet. So height in feet. Now again, let's get the numbering in here. It goes by 60s as well, so that would be 120, 180, 240. Okay, it says graph the function. The vertex of the graph, well, if we look right here, there's the vertex, 300 and 150. So 300 and 150. It's important that you realize this is in context of a problem. So that means from the left end of this bridge, 300 feet is the top point of that bridge. So right here is 300 feet. That's going to be the middle of your arched bridge. Okay, so let's go ahead and put it at 150. This is 120 plus 60, would be 180, so it's a little bit below that. Probably right down about there. Okay, again, graphing is oftentimes an estimate. Find the point at the left end of the support, x equals 0. Okay, since f of 0 equals 0, well, let's make sure that it does. 300 squared is 9. 1, 2, 3, 4 divided by 600. Mark those two out, 6 goes in there once. 30 left, 150, and that's a negative because it was a negative 600 that you divide by. Negative 150 plus 150 is 0. Okay, I just wanted to make sure it makes sense that we start the structure of the bridge right here at that level, but you want to always double check your math and make sure that it makes sense. If math doesn't make sense, then you need to back up and rethink things. So here's kind of the support of this bridge. I'm just sketching it in. Now anywhere on this side of our axis of symmetry, I can repeat over here. So since it was 300 to the top edge of the maximum support, then it's 300 to the other edge. The point 0, 0 represents the left end because it says it's coming from the left. Use the symmetry to find the point at the right end of the support. That's what I just explained. Since the left end is 300 feet to the left of the vertex, the right end will be 300 feet to the right of the vertex. The point 600, 0 represents the right end. Find two other points on the support, and they give you 120, and they give you 480. So you can estimate them off the graph, or there is another way that you could figure them out. And I'd like to know what other way you could figure those out. Come to class tomorrow as we get ready to do these problems, explaining another way you've thought of that you could find the answers to what height this is, a more accurate way. Okay, so I'm going to mark ask students. Other way. So think about that. Okay, determine the maximum height of the support. The maximum height of the function would be at your vertex. That's your maximum. So that would be at 150. So the maximum height of the bridge support is 150 feet. Determine the width of the bridge support at the level of bridge deck. Well, how can you find the width here? You explain that and give me the answer. Explain how you know that the y-coordinate of the right end of the support is 0. Okay, and it has to do with the symmetry. They're just asking, how do you know this is at 0? What does the vertex represent in this situation? You need to explain this in the context of the bridge. Explain how far over your horizontal distance is, how high up it is on the bridge support. Always use the context of the situation when you're asked, what does it mean? And it's a word problem. Okay? Now we get to the practice. This is what we'll be doing tomorrow in class. Graph each quadratic function and identify the vertex, minimum and maximum, axis of symmetry, and the zeros of the function. Doesn't matter which one we choose. I guess I would go with this one to help you first off. The other three I think are real doable, so we'll be doing these in class tomorrow. So the first thing that you want to do is you'll write vertex, just to set it up, and remember that's your HK, so I write that. And then minimum or maximum, you can look at the sign. If it's a positive, you know it is a U shape like that. Smiles are positive, that's what I always think. And they have a minimum point. Now when it's a negative in front, it's a frown. So it's a maximum, okay? Because that's the maximum point. Your axis of symmetry, A of S, is your K value, or I mean your H value. Just take it right out of there. The zeros of the function, you could have 1, 2, or none of those, and you find those by where it crosses the x-axis. Okay, so that's how I would set it up. Come to class tomorrow. We're going to practice all of these. I'm probably going to have some of you guys teaching some of it, and we'll go over these other problems. Thank you very much. That was 2-3.